introductory phase, some additional exchange are required for the privacy agreement subphase, and during the policy evaluation phase, the disclosure policy exchange can be executed together with some P3P policy exchange, which are targeted for the exchange of the credential information. So about the issue of anonymity. Our work on anonymity started, of course, with some questions or some questions about how and whether anonymity is actually an issue in the trust negotiation context. So since the trust negotiation is, as I said at the beginning, is very general and it can be applied in different scenarios, it turns out that actually for many trust negotiations, it might be very useful to have anonymous negotiation. Also because a subject may not want different negotiations to be linked with him. So to reach this non-linkability, or to reach to this non-linkability requirement, we do need to have some protocols or some mechanism to ensure that every single negotiation is anonymous. This is, for instance, the case like in bidding auctions or other contests where the identity of the user is not really important, because in most of the times what the other party is interested in while negotiating is not the actual identity of the user, but it's just some properties that are not necessarily related with the identity. So in order to address the issue of anonymity in the trust negotiations, we first have to define and to clearly understand which are the identifiers, which are the information, the attributes that actually cause identity disclosure. So we defined these two different concepts. First, the concepts of identifier, and the second, the quasi-identifier groups. These terms are borrowed from some work on k-anonymity, and there are a lot of overlapping concepts from our work with that work. The main difference is that in that work they work in database environments, while here we are dealing with open environments. So there are other issues that have to be considered. So by the way, this concept of identifier is simply an identifier is simply a single concept, a single attribute that uniquely identify a user, while a quasi-identifier group is basically a combination of attributes and then of concepts, if we consider it at a higher level perspective, a combination of concepts that uniquely identify the user. So anonymity preserving disclosures means that no identifier in each of the disclosure sets that have to be disclosed during the negotiations contain an identifier, and even if a quasi-identifier group need to be disclosed, at least one of the quasi-identifier is missing. So we need to work again on this disclosure set and see whether we can modify the disclosure set in order to make it anonymous. If we found out that either an identifier or a quasi-identifier group is revealed. So we adopt two different techniques. One is the substitution, and the other one is the generalization. So starting with the substitution, supposed to have a disclosure set, and the disclosure set, as I said earlier, there's a combination of attributes that need to be disclosed in order to satisfy a given policy. Supposed to have the attribute ID age and the attribute ID country in a disclosure set. And suppose that, for instance, that ID age is a requested attribute while ID country is a non-requested one. So we want to hide ID country, but because it causes revealing of anonymity, since it belongs, we assume that it belongs to a given quasi-identifier group, and we want to hide it. But in order to replace it, we also need to hide the ID age. Here, this is because I am here assuming that the privacy enhanced credential scheme is not always available. So if I have to hide an attribute, the attribute country, since it belongs to the attribute to the credential ID, I also have to hide all the attributes that are in the same credential. Or it might also happen that I actually do have a credential, a privacy-enhanced credential, but not all of the attributes can be blinded, and ID counter is one of the attributes that cannot be blinded. So to preserve anonymity, what I do is first try to suppress the attribute counter, and if you have if in order to do that, I also have to hide the attribute's age, I might end up not satisfying the policy because ID age was a required attribute. So what I do is to substitute the attribute ID age with an equivalent one, for instance, the date of birth. And this I can do it easily since I can rely on my ontology, and the ontology tells me which are the equivalent attributes and how to map a given attribute in another one. And if there are any condition, I can also check using the translation function that I mentioned if the same condition is verified. Regarding instead the other techniques that we adopted, that was the generalization technique, we rely on the use of a specific data structure, which is called concept graph, and this is an acyclic graph. And the idea is that to organize different concepts that the user has using a generalization relationship. So this concept is used for the generalization technique. And how is it used? Suppose that ID address is a requested attribute and causes an identity disclosure. So similarly as we do in the substitution, we replace the attribute with another one which does not cause identity disclosure. But if we cannot substitute it with an equivalent one, because the attribute itself need to be disclosed to satisfy the policy, the only thing that you can do is to generalize it, to give a more general one, and hope that a more general attribute will anyhow be accepted by the counterpart to satisfy the policy. So in this case, if I have I have the address, I'll check if there exists a more general concept for the concept address, and see if I have any attributes that are mapped into this more general concept that is, in this case, is CT. So this is just an example. This is just an example on how all this process works. So we have a disclosure policy and two different disclosure sets that can both satisfy our policy. Of course, a privacy conscious subject will also always try to submit the smallest set. So it will try first to submit the second disclosure set, but if it cannot, then it will disclose the other set, and eventually, if it's required, it will run one of those two protocols to preserve anonymity of the user. So these were like the first work that the initial work that we did on the anonymity. Of course, these protocols are kind of are not as straightforward as they might seem, because there are a lot of issues that are related with anonymity when dealing with open environments like those in which trust negotiations take place. First, we need to exactly identify which are the identifier and the quasi-identifier groups that actually identify a user, and this is not as trivial as it was, as simple as it was in the database environment.